Welcome back, guys. Tactical AV here. It's come time that we have a small lesson or class on amplifier circuit topology. What are the different classes of amplifier designs? Let's get started. Plus, you might learn a thing or two. Alright, let's start with the basics of an understanding of what am I talking about and why is this important. First of all, let's explain, or get to the understanding at least, that there are separate circuit topologies and different type of amplifier design circuitry. And those are called classes. Class A, B, AB, C, D, G, H, so on and so forth. But really, the different class gives us a broad indication of the amp's characteristics and, really, performance. But believe it or not, the classes are actually related to the time period that the active amplifier device is passing current, and that's mainly expressed as a fraction of the period of the signal waveform being applied to the output. But first I'm going to start with good old Class A amplifiers. And a Class A amp is conducting all throughout the period of each signal, whereas a Class B only for half the input period. And, well, Class C is much less than half the input period. But Class A is really thought of the holy grail of power amps. But this is the class that real audiophiles generally look for a power amplifier. What's important to remember is that a Class A amplifier is 100% of the input signal being used. So really the conduction angle equals 360 degrees, or an entire sine wave. The active elements remain conducting all of the time. So Class A amps conduct over the entire range of the input cycle. Well, and Class A amps are distinguished by the output stage devices technically being biased for Class A operation. So if we get an idea of a sine wave, and we see that right around this point is 360 degrees, and once we've gone from 0 to 360 degrees, a Class A amplifier is conducting all throughout that cycle. You see, because Class A amplifiers were technically the first design to exist, and, well, they're a simple design, as opposed to other classes like A, B, and B, which technically require two connected devices in the circuit, and each one of them handles half of the waveform, whereas generally the Class A just uses a single device, hence it's single-ended. And technically the amplifying element is biased, so the device is really always conducting. The quiescent collector current for transistors and drain current for MOSFETs or vacuum tubes is close to the most linear portion of the transconductance curve. Okay, then, with Class A amps, because there's never an off time and they're really always turned on, well, there's no problems with the charging or storage or time to turn on, time to turn off, and for another playing device to take the task of the first one. Which generally means a higher frequency performance with better stability and, well, less higher order harmonics. But Class A power amps are generally meant for lower power needs. But Class A amps are technically the least efficient. They produce a ton of heat, they're large, and, well, they're an older design. As you can see, Class A amps are actually the least efficient amplifier design that exists, but does have a very accurate sound reproduction. Now, downside to this as well, energy hog, runs hot, it's inefficient, and oftentimes can cost a lot of money. So what's the next letter in the alphabet? Well, B. And I'm not going to get too technical or go into things in too much depth here, but I do want to say that the Class A amps are extremely inefficient, and we understand that. In fact, they can only get to about 25% efficiency, and that's with normal designs, and 50% is the maximum for a transformer or inductively coupled configuration normally. So, in power amplifiers, it really wastes power and limits the operation, and will increase the costs and requires higher rated output devices. You see, in a Class A amplifier, if high output power is needed, well, the power supply and heat become extreme. For every watt delivered to the load, the amp, really at best, uses an extra watt. So for high power amps, this means, well, expensive power supplies and extremely large heat sinks. So we talked about Class A being active for 360 degrees of the waveform, or an entire waveform period. In a Class B, the active device actually conducts for half of that, 180 degrees of the cycle. Now, it causes immense amount of distortion if there's only one device handling that. That's why they use two different devices, and, well, each of them conduct for half of the cycle, 180 degrees. And the device currents are combined, so really the load current is continuous. So in a Class B amplifier, once we get to the waveform point of 180 degrees, the other device takes over and operates the other 180 degrees of that waveform, completing the cycle. Now, what is the problem with this? Well, crossover distortion, you guessed it. They say a Class B amp can technically be 78.5% efficient. But as I pointed out before, what's the downfall? Yes, crossover distortion. So as I explained before, guys, there's two different devices to handle that waveform, and when one device switches off to the other, and the handoff between the devices handling the positive and, well, negative current, it's at that point that the crossover distortion can occur in Class B amps. In fact, I'll actually be devoting an entire video to analog amplifiers only, and Class B push-pull vacuum tube stage power amplifiers particularly. But nonetheless, Class B is a pretty popular class among itself. So I won't touch among top Class B amps too much in this video. However, I do want to point out the fact that on the upper hand, Class B amplifiers are more efficient than operating in Class A amplifiers. Well, the downside, when they switch off at 180 degrees of that waveform and the other device takes over, there's a reduced sound quality because of that crossover distortion. And so the next best thing to arrive. You guessed it, Class AB. So as you might think, one would put together a Class A and a B amplifier to create something a little bit more efficient and, well, more powerful. And that's exactly what we did. In fact, Class AB amps dominate the consumer market and are one of the most popular style of circuit topologies you'll find in the audio market today. But the main point here is that instead of a Class B, which is in a push-pull arrangement where half the output stage conducting for 180 degrees, a Class AB amp tries to take that number to about 180 to 200 degrees, where they're switching off of the waveform. And that's in efforts to cut the gap in the cycle, where most of these companies today are able to get the crossover distortion down to the point where it's of no consequence or completely inaudible. But by doing this, they're able to maintain the sound quality of a Class A amp and, well, looking for the efficiency that a Class B amp's able to provide. And they do this by simply running in Class A mode when there's not a lot of power desired. So when you don't need a lot of volume or power, they're going to run in Class A. Simply, when you turn up the volume, they're going to switch over to Class B. So the trickle of voltage that flows in the output device, and technically they're still biased, it's kept on for longer, so the push-pull effect minimizes any distortion at the point of where they cross over the waveform from positive to negative and back. So this technically makes the amp faster, but think about Class AB amps all but eliminate the non-linear problems of Class B amps, and they also ramp up the efficiency to Class B levels or more, typically around half. They still run hot, but nowhere near like a Class A will run. And well, in case you were wondering, yes, Class AB amps are the most common type of power amp you're going to see in home theater and among home audio. In fact, if you look at a company like Emotiva, I could not find any amplifiers that they produce that are not Class AB other than this one. This is the only Class D amplifier that I have found that Emotiva makes so far. So when we were moving from Class B audio, we were having an issue with crossover distortion at that 180 degree wave point. Well, an improvement so far is to bias the devices so that they're not completely off when they're not in use, and that's AB operation. You have to remember, because that conduction angle is actually intermediate between Class A and B, and the two active elements conduct more than half the time. Now, technically, in the engineering world, it's been said that the exact choice of quiescent current, that's the standing current through both devices when there's no signal, can really make a big difference to the level of distortion and to thermal breakdown that causes devices to shut down. And ultimately, there's a bias voltage applied to set the quiescent current, and that's adjusted really by the temperature of the output transistors. You know, and in fact, it wasn't until a few years ago that I really cared to know as much as I can about this. And I was working a lot with BGA technology, or ball grid array soldering technology. But that's really when I ultimately found out that the Class AB amps sacrifice efficiency over Class B amps do in favor of linearity. And that's why they're less efficient below 78 for full amplitude sine waves, at least in transistor amps, typically much less in AB vacuum tube amps. And I should probably throw this out there, that they do claim that there are suffix numbers for vacuum tube amplifiers. Although I've never actually seen them on the market, it's something I've been interested in for quite a while, ever since I was a kid, actually. For instance, like B1, and 1 indicates sometimes that the grid current, does or doesn't flow in any part of the input waveform, which all has to do with the driver stages, obviously. But there's no numbers used for semiconductor amplifiers, technically. So I'll make sure and have an entire video with stories on how I got interested in tube amplifiers and all that, and different ones I've owned over the years, but I will be devoting an entire separate video to Class B and push-pull or vacuum tube stage, single-ended triode and whatnot. Now, I'm going to kind of skip over Class C, or at least I'm not going to really mention it. If we notice, the Audioholics website here doesn't even bother to include Class C, and it's not a very, applicable topic among audiophiles, at least. In fact, most websites are going to leave Class C kind of off of there. But if we go back to our waveform, technically a Class C amp, 50% of the input signal is used, so the conduction angle is less than 180 degrees normally. And technically what happens is distortion is high, and practical use requires you to tune the circuit as a load. Because technically Class C amps that have two different types, tuned and untuned. Some people refer to tuned amps as clamper and restores the waveform to the proper shape, despite, the amplifier having only one polarity supply. But technically the thing to remember in Class C amps, now think of radios and transistor radios and whatnot, but the active element conducts only while the collector voltage is technically passing through its minimum. Power dissipation in the active device is really minimized, and efficiency, it's really at a maximum. But usually stuff that's operating on a single fixed carrier frequency. But that brings us to Class D, one of my favorite classes in the recent history. And I will point out there that they're technically not considered a digital amplifier. I'd rather not open this topic up for debate, but Class D amps are not considered digital. But here's where things really change. This is the first time we're not using linear devices. And this time, the conduction angle of each device actually has no relation directly to the input signal. Actually, it varies with pulse width this time, guys. But yeah, quite an interesting topic. Pulse width modulation. What is it, and what does it mean? And lucky for you guys, I'll actually be devoting another video to Class D amplifiers particularly. But now we're talking about pulse width modulation, and that's used for controlling the amplitude of digital signals in order to control devices requiring power or electricity, technically. But in any Class D amp, the active devices, transistors, function as switches, electronic switches, instead of the linear gain devices we were working with A, B, and AB amps, and they're either on or off. The analog signal that comes into a Class D amp is converted to a stream of pulses that represent the signal by the pulse width modulation. It's the density and the delta sigma modulation or related modulation technique being applied here, and it's this that becomes quite interesting. You see, the time average power value of the pulses is directly proportional to the analog signal that was coming in. After amplification, the signal is converted back to an analog signal by a passive low-pass filter this time. And well, the purpose of that output filter is to technically smooth the pulse stream to an analog signal, removing any of the high-frequency spectral components that the pulse produces. You see, the frequency of the output pulses is actually 10 or more times the highest frequency in the input signal that's being amplified, so the filter can adequately reduce those unwanted harmonics and accurately reproduce that incoming signal that was originally there. It's those tops of the waves that we're trying or attempting to smooth off here. You see, we don't want flat lines or jagged edges. We want a nice, smooth, curved sine wave to appear. So what's the biggest advantage of using this pulse width modulation versus having heavily biased output devices, transistors, vacuum tubes, what have you? You guessed it, efficiency. The main advantage of any Class D amp is power efficiency. Those output pulses have a fixed amplitude, so the switching elements are called MOSFETs, sometimes called vacuum tubes, and yes, at one point they all were bipolar transistors. But think about it, they're either switched completely on or they're switched completely off, rather than operating in a linear mode. You see, a MOSFET operates with the lowest resistance when it's fully on, and, well, excluding it when it's fully off, and it has the lowest power dissipation when it's in that state. You see, if you were to compare a Class A, B amp to a D, the Class D amp's lower losses really allow it to have smaller heat sinks for the MOSFETs while reducing the amount of input power technically required, allowing for lower capacity power supplies, smaller heat sinks, smaller design in general. In fact, some of the Class D amps can actually operate from a digital signal source without requiring a DAC, or a digital analog converter, to convert the signal from analog first. That's simply because an MP3 player, a computer sound card, whatever it may be, your phone, the digital circuitry can convert the binary digital, that's why we think Class D is digital, signals directly into the pulse width modulation signal that's applied to the amp, simplifying the circuitry considerably for digital devices. You see, I've done a lot of work with motor control in my life. In fact, my whole life growing up was mainly about motor control. And they did back in the 80s and 90s, and they still today use Class D amplifiers for motor control applications all the time. Okay, so if these Class D amplifiers are so great then, and they're designed so much better than a Class A, B, or push-pull design, what's the downside to these, and, well, what's the distortion like and sound quality compared to those other linear amplifiers? Well, and here's the deal with that. You see, high-quality, high-fidelity, high-end Class D power amplifiers are now showing up on the market everywhere and for affordable amounts. You see, these designs have been said to rival the traditional AB amplifiers in terms of, quality. Now, everyone who's worked with car audio in the past has known about Class D amps and their application of, well, high-powered subwoofer designs in cars. And that's generally because subwoofers are technically limited to a bandwidth of, say, less than 150 hertz, so the switching speed for the amp doesn't have to be as high for, well, a full-range amplifier, allowing for simpler and, well, less costlier designs. You see, Class D amps for driving subwoofers are relatively inexpensive in comparison to, say, a Class AB power amplifier for home audio use. But it's when they use them with the switch mode or switchable mode power supplies that really gives them the ability to be used in a full spectrum application. You see, like the output stage, the power supply itself can rapidly be switched on and off to regulate the voltage, and that leads to further gains in efficiency and the ability to shed weight relative to traditional analog or linear power supplies. Now, one main downfall is that the switchable mode power supplies oftentimes aren't as linear, don't have as much power or dynamic headroom as some of the traditional linear power amps did. So usually the quality Class AB amps are able to produce a little bit higher power levels at the higher dynamics, but the switchable mode power supplies are becoming more commonplace now. You can expect to see them in high-powered next-generation Class D power amplifiers employing them, and, well, we've seen exactly just that. But getting to the end of our little illustration here, and remember, I said I'd have videos following up on some of these classes more in depth and talk a little bit more technical about them. But is there really one amplifier to rule them all? Is there one best type or class to go with? And that answer is simply no. This all depends on your desire, what you're looking for, the sound, the signature, and, well, where you're going to and how you're going to use this. But I do want to sum some things up here with help from Audioholics in a sense that we want to know at least that Class A is typically efficient of 15 to 35%, while B is a little bit more up there at 70%, while AB still lingering at around 50 to 70% efficiency, but there's no possibility of crossover distortion with A, and with B it's relatively high efficiency over A, but the con with A is its inefficiency in heat. I used to think of Class A as good old American V8 engines, whereas Class B or AB were more of the four-cylinder European and efficient designs compared to the American V8 that produced a ton of power and heat but wasn't that efficient. Class D being compared to as more of the supercars, say the Ferrari versus the Dodge Roadrunner being the Class A and D being the Ferrari. Whereas Class AB is more efficient than A, relatively inexpensive, crossover distortion can be relatively not existent, where efficiency is good but not great with B. And AB, I mean. Potential for significant amounts of crossover distortion and compromised fidelity in B, whereas A, we still have single-ended designs prone to hum and higher levels of distortion. If we do look at D, we see the best possible efficiency and lightweight. So for someone trying to save money on audio equipment, at this point it looks like Class D is going to probably be one of your best bets for saving money. Now, there still is a possibility with Class G and H to get a little bit better bang for your buck, so to speak, when buying amplifiers these days. But if high-quality, high-fidelity audio is really what you're looking for, it looks like you're going to be best suited with going with Class D or good old Class AB. You see, when most people set out to buy an amplifier, they're not necessarily asking themselves or banged with the question of what class or circuit topology would you prefer. Most people probably wouldn't even know what you're talking about. But when you consider things when it comes to cost, efficiency, and consequently weight, Class D amplifiers certainly hold the title over Class A being among that sense. But a 500-watt Class A amplifier, according to Audioholics, is a bad idea unless you're hoping to fry some eggs on it or use it as an oven. But you still got to think about this. The classes don't necessarily define the sound quality. In the end, that comes down to the engineering and implementation that was provided with that particular design. Every product is different. Most people are lucky enough to hear and somewhat measure a good example of all of them, but a lot of us don't get the time or possibility to even hear different amplifier designs or know the difference. Now, in fact, where this gets interesting is when we heard Audioholics tell us that there's three main contenders or quality amplifier manufacturers out there that are producing Class D amps, and those are ICE modules, Hypex, and none other than Pascal. And since these Class D amplifier modules have been gaining in popularity and momentum and a sense of quality audio fidelity they're able to reproduce, well, I decided to try to research that on my own. You see, if you just dig and do some simple research, you'll find out that a few people have already asked themselves these very same questions. What is the difference between the amps? Is there a difference? And what are the best amplifiers out there now, at least, for the money? And, well, for those of you that aren't aware of what companies are put into what products, well, I like to refer back to a good old brand that I've always had good luck with, Emotiva. You see, when I was shopping around for a new power amp and kind of comparing and wanting to know, well, what company is using which product's designs, well, it wasn't hard and didn't take me long to find out that, well, Emotiva has been using the ICE power modules. And, well, they've proven to be pretty effective in one of their Class D balanced monoblock power amps. And, well, Hypex is certainly doing their job, too, to get themselves out in the market. It's definitely easy to see that Hypex is spread a little bit more among the different brands and types of amplifiers out there, at least, but definitely saturating the market with some of their amplifier modules out. Which brings me to Pascal. You see, I did a little bit of research as to, out of those three contenders or producers of major Class D power amps, what were the audio industry individuals saying about those three brands, and what was the best one? And while it really wasn't a question of what was the best brand, it was more a question of what was each brand doing with their products and at what price were they available for? Which eventually brought me to Red Dragon Audio from HomeTheaterReview.com. You see, Home Theater Review had already reviewed two amplifiers by Red Dragon Audio that I had been interested in and had heard myself before. And I'm excited for my next video to be able to go through you guys what I was able to find out from my very own review and what I thought